Good morning students, welcome to the session. In this session we are going through the chapter multiple integrals. In this multiple integrals, first we will go through the basic prerequisites of this one, which is nothing but single integration. You are all aware of calculation of integral a to b f of x dx. Integral a to b f of x dx in our intermediate standard. So here that one is in our geometry. This is x-axis and y-axis. This is the curve equation, and here this is the x is equal to a and this is the x is equal to b. This is the region. So this is, along this we are calculating only this one. So for this formula is integral a to b f of x. So here this is lower limit and this is upper limit, and along a to b we are integrating this one. So and here this one can be written as integral a to b f of x dx can be written as, general format is limit integral limit n tends to infinity sigma n is equal sigma I is equal 1 to n f of xi delta xi. What is delta? Here this one we are cutting as different parts. These are all parts we are adding, and as n reaches to infinity this value becomes a finite value. That finite value is called an integral value. This is the standard form of the integral, but we know only integral a to b f of x dx. Now we are moving this one to the two-dimensional, which is nothing but this is x is equal to a to b and this is y is equal to f of x, and this is the region. This region we are calculating by using integral. That one is called double integral f of, here we are getting two variables x comma y dx dy, and this double integral formula can be written as limit n tends to infinity sigma I is equal to 1 to n f of xi comma yi, and here delta ri. R is nothing but region. What is this region? This region we are splitting as parts. So suppose this is the region. This region I want to calculate. For this we are splitting this one as small parts, and this is the small parts, and in this parts there is one region, ith region. This ith region form is sigma I is equal to 1 to n f of xi comma yi delta ri. This region length is called delta ri. So this total sum we are adding, and as limit n reaches to infinity we will get this value, double integral f of x comma y dx dy. This one we are extending to the three variables. Then what is this? Limit n tends to infinity sigma I is equal 1 to n f of xi yi zi delta vi. V is nothing but volume. So here also we are splitting in 3D the total value into different small parts, small volumes. That small volumes we are adding, then we are applying limit n tends to infinity. Then we will get triple integral f of x comma y comma z dx dy dz. So like this we are calculating. This is double integral and this is triple integral. So in this session, in this chapter, how to calculate double integrals, how to calculate triple integrals, we are learning in this chapter. So coming to the double integrals, how we are calculating the double integrals. So here double integral formula is this one. So double integral f of x comma y dx dy. So what are the double integrals? These are the double integrals. So these limits may be, here three types of limits are existing. If first part, if x comma y are constant limits, In this case, integral is integral a to b, integral c to d, f of x comma y, dx, dy. Coming to the second part, if x is constant, and y is in terms of f of x, then the integral is integral a to b, f1 of x to f2 of x. These are y limits, f of x comma y, dy, dx. Coming to the third one, y is constant and x is in terms of y. Then this integral changes as integral a to b. This one is g1 of y to g2 of y, f of x comma y, and dx, dy. In these three cases, we are calculating the double integral value, and here coming to this one, here both are constant limits. That means you have to make integration either with respect to x or with respect to y first. After that, make another integration. Here we will get directly either x or y we are doing. But coming to this one, here first you should do integration with respect to y only. Then you have to substitute in place of y f1 of x and f2 of x. Then this one changes as in terms of x. After that, make integration with respect to x. I will get the solution. Coming to the third case, in this case, first we are integrating with respect to x. We are substituting x limits as in terms of y. After that, you will get this total one is in terms of y. So integrate with respect to y, you will get the value of this one. These three cases are arriving in this double integral, and by using in this double integral, we are changing the variables. Suppose he given y in terms of y is in terms of x constant. You have to convert this one as x is in terms of x is constants, y is in terms of x. So that is called change of variables. That one also we are learning. After that, changing the order. So here see this one a to b, f1 of x. This one we have to change the limits. X is constants. You have to convert that one as y is constant. So like this, we have change of variables and change of order of integration. Here order of the integration we will vary. Change of variables means only in this function we are changing the variables. So this is called change of variables and change of order of integration. Now see this. Evaluate integral 0 to 2, integral 0 to 3 xy dx dy. Now here if you are observing this, here 0 to 3 constant limits, 0 to 2 constant limits, and this is double integral. In this integral, there is no we cannot find these are x limits and these are y limits. And that's why we are following the order of this one. Whatever he given, we are following this order. If both all limits are constant limits, and here he given first of all x. So first limits are these are the limits of x, and these are the limits of y. So first take integral 0 to 2, 0 to 3 xy dx dy, which is equal to 0 to 2. First make with respect to x. If you are making with respect to x integration, you have to treat y as constant. This one, this type of situation existing in partial differentiation. Same case here also we are doing. With respect to x integration means you have to treat y as constant. With respect to y integration means you have to treat x as constant. So here we are making first with respect to x integration, treat y as constant, y into x integration is x square by 2. What are the limits of x? 0 to 3 into x integration completed, which is equal 0 to 2 constant right outside y by 2. First write upper limit x square 8 minus lower limit 0. So which is equal to 8 by 2 constant right outside 0 to 2 y dy. 8 by 2 means 4. Integration of y with respect to y is y square by 2. Upper limits and lower limit 0 to 2. Write 2 outside, upper limit 4, lower limit 0. 2 times getting cancelled, 2 into 4. So 2 into 4 value is what? 8. So this is the value of the evaluate integral 0 to 2, 0 to 3 x, y, dx, dy value is 8. And similarly, we are going through the one more problem. And here if you are observing this, say this, evaluate integral 0 to 1, integral 0 to 1 by square root of 1 minus x square into 1 minus y square into dx dy. Here also he particularly does not mention what are the limits of x and what are the limits of y, and that's why we are going through this order. And here these first limits are a, first one is x, so these are the x limits and these are the y limits. Now in the same way consider 0 to 1, 0 to 1, 1 by right root 1 minus y square into root 1 minus x square into dx dy, which is equal 0 to 1 with respect to x means y treated as constant into 1 by root 1 minus x square integration sine inverse x, limits are 0 to 1 into dy, which is equal to integral 0 to 1 by root 1 minus y square into upper limit value is what? 1, lower limit sine inverse 0 into dy. Sine inverse 1, when sine becomes 1, 90, sine inverse of sine 90 is 90, integral 0 to 1 by root 1 minus y square into 90, constant sine inverse 0 0 into dy, pi by 2 into, again integration of 0 to 1 by root 1 minus y square dy is sine inverse y, limits are 0 to 1, which is equal to pi by 2 into sine inverse 1 minus sine inverse 0, which is equal to pi by 2 into, when sine becomes 1, 90. So pi by 2 into pi by 2, which is equal to pi by 4. Like this we are doing if both limits are constant limits. Now we are going when one term is in function of x, another one is in terms of y. Now integral 0 to 1 evaluate integral 0 to 1, 0 to x, y, dy, dx. This value we have to calculate. So how we are calculating? See this integral, and if you are observing this, and here there is a variable x existed, in that's why these are the limits of y. Other variable is what? Y. So these are the variables of y, limits of y. Other limits are x limits. So integral 0 to 1, integral 0 to x, y, dy, dx can be calculated as integral 0 to 1. Y with respect to y integration is what? Y square by 2, limits are 0 to x dx, which is equal to 0 to 1, 1 by 2 right outside, y square, upper limit x square, lower limit 0. So which is equal 1 by 2 into, what is the x square minus 0? X square. X square integration is x cube by 3, limits are 0 to 1. 1 by 2 into upper limit 1 by 3, lower upper limit 1 by 3 value 1 by 3 minus 0 by anything 0, which is equal to 1 by 6. So this is the value if one is in terms of other variable, then this one treating as here x is existed, and that's why these are the limits of y, and one limits existed, obviously other one becomes another limits, so that means this is the limits of x. Similarly, we are going through the one more problem. Solve integral 0 to 1, integral 0 to under root of 1 plus x square into 1 by root 1 plus x square plus y square into dy dx. First you have to observe clearly what are the limits of x and what are the limits of y. And here if you are observing that this integral consisting the variable y x, in that way these are the limits of y, and this one does not have one variable existed, obviously this becomes the limits of x. Now solution: integral 0 to 1, integral 0 to under root of 1 plus x square. First integration is 1 by root 1 plus x square plus y square into dy dx. So here I am erasing this. Which is equal to integral 0 to 1. For our convenience, take 1 plus x square as p. 1 plus x square as, for example, p square. Take it as p square. Then this becomes 0 to under root of p square. 1 by under root of 1 plus x square treated as p square plus y square into dy dx. And here observe this, here square root does not exist in this problem, so square root is in another problem. So here 1 by 1 plus x square plus y square. Here also square root not existed. So this one 1 by p square plus y square. If you are observing this, here what is the variable? Y is the variable. So it is constant. It is of the form 1 by a square plus x square. What is the integration of 1 by a square plus x square? 1 by a tan inverse of x by a. So 0 to 1. 1 by a. What is the value of a? P. 1 by p tan inverse of variable. What is the variable? Y by a value is p. So what are the limits? Y limits are 0 to under root of p square. 0 to under root of p square means 0 to p, which is equal to integral 0 to 1 by p. Substitute upper limit, p by p 1, tan inverse 1. When tan inverse 1? Pi by 4 minus lower limit 0. Tan inverse 0 value is 0. Now which is equal to, write this pi by 4 outside as it is. And what is remaining? Integral 0 to 1 by p. What is the assumed value p? P is 1 plus x square. So write as it is 1 plus x square dx, which is equal to pi by 4 into 1 by 1 plus x square integration is tan inverse x. What are the limits? 0 to 1. When tan becomes 1? Pi by 4. So upper limit is pi by 4. Lower limit is 0. So pi by 4 into pi by 4, value becomes as pi square by 16, which is equal to pi square by 16. So this is the value corresponding to the problem integral 0 to 1, integral 0 to under root of 1 plus x square into 1 by 1 plus x square plus y square. Problem is, I written square root, there is no square root, only 1 by 1 plus x square plus y square dy dx. Evaluate double integral r y dx dy, where r is the region bounded by the curves y square is equal to 4x and x square is equal to 4y. So here first of all we are drawing corresponding to the picture, and this is x-axis and this is the this is x-axis and y-axis. Now here y square is equal to 4x, so y square is equal to 4x curve. Next, x square is equal to 4y, so x square is equal to 4y, and this is the common region. And what is this curve? Y square is equal to 4x. And here, what is the curve of this one? X square is equal to 4y. Y square is equal to 4x and x square is equal to 4y. And these two are intersected at the points, and this is one of the point origin and this is another point. Assume this point as A. So these 2 points are existed by the intersection, these intersection points of y square is equal to 4x curve and x square is equal to 4y curve. So we are calculating the intersection points of these two. So here, what is the value of y? X square from the curve x square is equal to 4y. What is the value of y? X square by 4. Substitute y x square by 4 in this, then we will get, say this, y square is equal to 4x. Y square is equal to 4x. From this equation, y is equal to x square by 4 whole square is equal to 4x. So this one is x power 4 by 16 is equal to 4x. So x power 4 is equal to 64x. So x getting cancelled. So what is remaining? X cube is equal to 64. So which is nothing but x is equal to 4. So how we will calculate x is equal to 4? See this here. Here say this, x power 4 minus 64x is equal to 0, both having the common x cube minus 64 is equal to 0. That means x is equal to 0 or x cube minus 64 is equal to 0, which is nothing but x is equal to 0 or x is equal to 4. If x is equal to 0, so substitute x is equal to 0 in x square is equal to 4y, then I will get y is equal to 0. One point is 0, 0. If x is equal to 4, substitute x is equal to 4 in this, 4 square 16, 16 is equal to 4y, that means y is equal to 4. So another intersection point is 4, 4. So 2 points are existed, one point 0, 0 and another point A is 4, 4. Another point 4, 4. After this, here I am calculating the remaining part. Here I have to calculate double integral r y dx dy, which is equal to, observe clearly, here I want either x strip or y strip. What is the x strip? What is the y strip? First I will calculate x strip. See this, x strip means this is called x strip. That means x variating in terms of y. X variating in terms of y. I want x is in terms of y, which is, see this, x. If you are moving in this side, first curve is this one. So what is this curve? Y square is equal to 4x. From this, what is the value of x? Y square by 4. This becomes the lower limit. After that, if you are moving from this side to this side, then only upper limit existing. So this is the upper limit part. From this, what is the value of x? X is equal to square root 4y. These are the x limits. Coming to the y limits. Y limits becomes as constant limit. So y means this one. So corresponding to this point is 0, 4. So this is 0, this is 4. So limits of x are 0 to 4. And this one is y. And these are the limits of x dx dy, which is equal to integral 0 to 4 y into, what is remaining? 1. One integration is x. Limits are y square by 4 to square root of 4y into dy. Now simplify this integration, which is equal to 0 to 4 y into upper limit. What is the value of upper limit? Square root 4y minus lower limit y square by 4 into dy. Simplify this one, which is equal to 0 to 4 square root of 4 value 2 into y into root y into y cube by 4 into dy, which is equal to 0 to 2 into y root y can be written as y power 1 plus 1 by 2 value is 3 by 2 minus y cube by 4 into dy. Now make simplification of this one, make integration 2 into, it is of the form x power n. X power n integration is x power n plus 1 by n plus 1 minus 1 by 4 into y cube integration y power 4 by 4. Limits are 0 to 4. So 2 into 5 by 2 can be written as 2 by 5. Upper limit 4 power 5 by 2 minus 1 by 16. Upper limit 4 power 4. Coming to the lower limit, this becomes 0 and this term becomes 0, which is equal 2 into 2 by 5. 4 can be written as 2 square. 2 getting cancelled. 2 power 5. 2 power 5 value is 32 minus 4 square 16. 16 getting cancelled. Remaining one is 16, which is equal to 2 into 32 2s are 64 by 5 minus 16, which is equal to 64 by 5, 2 into LCM 5, 64 minus 80, which is equal to 2 into minus 16 by 5. And here one more problem. Evaluate double integral r xy into x plus y, where r is bounded by y is equal to x square and y is equal to x. So here first of all we are drawing this corresponding diagram. Y is equal to x square is the upward parabola and y is equal to x is the straight line which is passes through the point origin and straight line, and here this is the straight line. So this straight line is y is equal to x and this is the upward parabola, y is equal to x square. Now I want the intersection points of those two. Substitute y is equal to x in this. So y is equal to x square. So y value x is equal to x square. So x square minus x is equal to 0. X into x minus 1 is equal to 0. That means x is equal to 0 or x is equal to 1. So if x is equal to 0, what is the value? So if x is equal to 0, right, x is equal to 0 in this curve equation, then obviously y is equal to 0. X is equal to 0 implies y is equal to 0. Point is what? 0, 0. So this point is 0, 0. Another one is if x is equal to 1, then what is the value? Y value 1. So another point is 1 comma 1. This point is 1 comma 1. So here region is this one. This is y is equal to x and this is y is equal to x square. Now we are taking double integral r. What is the common region? This is the common region. Double integral r xy into x plus y into dx dy. Dx dy, which is equal to. Now observe this. Here, which value we have to calculate? First, what are the limits of x and what are the limits of y? We have to calculate. So here, I will calculate along vertical strip or horizontal strip. In previous problem, I calculated along horizontal. Now, I will calculate along vertical. So that means I will take y limits along vertical. Y is in terms of x. So which is y is in terms of x means y moves in this side. So what is the first one? First curve is this one. From this, what is the value of y? X square. It is ending along straight line. So upper limit is x. Y is equal to x square to x. Coming to the constant limit. So corresponding to this, what is this point? 1, 0. So x here 0 and here 1. So x limits are 0 to 1. Xy into x plus y, multiply inside, xy into x value x square y plus xy into y value xy square into, and these are the limits of y. First make integration with respect to y, next make with respect to x, which is equal to 0 to 1. With respect to y means x treated as constant, x square into y integration y square by 2 plus x into y square integration y cube by 3. Limits are x square to x dx, which is equal to integral 0 to 1 x square by 2 into upper limit value is x, lower limit value is x square. So this one x square minus x power 4 plus x by 3 into upper limit x, x cube, lower limit x square, x power 6 into dx. Now we are simplifying that value, which is equal to, so here I am erasing this. And say this, which is equal to integral 0 to 1 x square into x square x power 4 by 2 minus x power 6 by 2 plus x by 3 into x cube x power 4 by 3 minus x power 7 by 3 into dx. Now make integration of this one, which is equal to 0 to 1 x power 5 integration x power 5 by 5 2s are 10, x power 7 by 7 2s are 14 plus x power 4 integration x power 5 by 5 3s are 15, x power 7 integration x power 8 by 8 8 3s are 24, and limits are 0 to 1. So I completed the integration. Now I will simplify. Upper limit 1 by 10, 1 by 14, 1 by 15, 1 by 24. If you are simplifying this total one, you will get this value as 3 by 56. So like this, we are calculating the region integration, the region value. If you are taking horizontal strip, you are taking x is in terms of y as constant. If you are taking vertical strip, you are taking y as in terms of x as constants.